I also predicted that this private forms of 5G would capture all momentum and creativity. And that's why I've been a supporter of ASOCS from the beginning, which is taking this vector of technology advance that is allegedly 5G and sort of some sort of fixated, establishment mandated, government ordained, regulated, militarily alarmist, will China get 5G before we get 5G? I mean, and other such dubious fears. And focus on the actual companies that are advancing wireless. And one of my favorites is Gilad's, and he's been my guide for in wireless technology for a decade or so now. And so, Gilad, why did you form ASOCS, and how has it evolved, and what do you think's the future of 5G now as they the evolving future that's generated by entrepreneurial creativity rather than some set of government bureaucracies or government-like bureaucracies?
Thank you, George. So actually, it's been 18 years. I don't really remember. So let's focus on the here and now and technology, okay? Let's not dwell in the past.
It's a fascinating past.
So let's start with the end, George. You're dead wrong. Because it's actually the opposite. I promised in the beginning when I was told we'll moderate it, that we'll not talk about Wi-Fi. Actually, Wi-Fi, I think you're confusing deployment methods and technology. Wi-Fi is very well organized. It's very, very dull in what it does, and that's why it was so effective in being disruptive in consumers. 5G seems to have was defined when there was maybe because of COVID, there was no adult supervision, and the engineers, they went wild, and they defined, I think we once calculated about 500,000 parameters that could be changed in a 5G network to tune it to separate things.
5,000 different parameters.
No, 500,000.
Oh, okay.
And what it means is that the different types of 5G that could be built are in numbers that I don't even know how to describe. So you're right that what is confusing is that people look at cellular, they see big telco. So, 99% of telcos give the 1% a bad reputation, right? So that is your confusion. So once we put that out of the side, let's drop this Wi-Fi versus 5G because it's no match, really. What 5G actually, why 5G is so exciting, other than the fact that I can build a 5G that has nothing to do with the other guy's 5G, and I'll give you one intuition. The 5G that is applicable to iPhones has nothing to do with the 5G which is applicable to a robot. The robot is uploading information, it needs super low latency and positioning. An iPhone could care less about all these three parameters. So that's just one intuition. The other big thing, and it's time we let Steve talk, is the way we implemented 5G. So Wi-Fi is still a chip. You can buy it from either Broadcom or Qualcomm, which reminds me of the Blues Brothers story that they said they play both kinds of music, both country and Western. You have two choices, all right? In 5G, this is going out of control. You can run it on Microsoft, on Azure, on Dell, on VMware, on Red Hat. And because this is, I failed to mention, a software technology, an IT technology, and not a telco or hardware-driven technology, the amount of innovation which is happening in 5G is just incredible.
So it's not really 5G if you aren't talking about the big telco 5G programs, which they develop these standards, they are proclaiming them, and the government's adopting them, and your 5G is a different proposition. It's just It's just an umbrella for all innovation in wireless, as far as I can see.
Are you asking or are you telling?
Well,
That's not true, guys.
you can tell me.
Okay, so the real trend that's happening in 5G is 5G private networks. So the macro stuff, you know, this 5G E, AT&T thing that I tried to look at my football results this evening, that doesn't work, that's not 5G, okay? So the 5G private, the real innovation is happening in what is so-called these 5G private networks. So 5G private networks are enterprise-driven worldwide, in Germany, in Japan, in South Korea, and yes, even possibly one day in the United States of America over CBRS or some other frequency once they get their act together. So 5G private networks for industries, that's the big deal. Not the consumer crap that you guys think you have. You don't. So that's number one. Number two is the way you deploy it. And as we mentioned, because this is software, this is starting to become the game of the hyperscaler. And without further ado, let's let Steve talk about that.
5G is a marketing term, something simple people can grasp. 5G in implementation is about low latency on the edge. It's about being close and fast and spread out and diverse and specific to its need. Different in a hospital than it would be in a factory, but it's about speed. We have cloud ubiquity, but we can't reach that last mile, so to speak. You need something like 5G to actually connect to real devices at large scale and high speed right now. And it's rolling out between many vendors, including us. The consumer is super important. Don't get me wrong, everybody is a real person at the end of the day, except for the robot, the factory floor machine, the elevator. And they are all actually consumers in this scenario. So it's important that there is the right kind of connectivity in the right kind of place. I think Wi-Fi and Wi-Fi 6, they're perfectly fine, but they are not low latency. They're just sort of this generic hum that sits in the background. Everybody can get to it. It's made it possible for people to think about the future of wireless. Before, if you weren't always on your cell phone today, if you weren't at home just randomly connecting to things, and we came in and said, you know what we can do? We can connect every device, everywhere, all the time. People would think it was absolute fiction. But today, it's assumed. It's actually assumed that it works, and it doesn't. We're getting there, but not yet.
Again, if I didn't stress it enough, you guys are not going to enjoy 5G on a personal level. You could invest in stocks that operate 5G private networks, but you're not going to enjoy it as consumers. Perhaps one of the, I'm talking about on the mobile phone, perhaps one use case, and that was over edible, was the autonomous cars that were supposed to run on 5G, and let's not go in there. So let's talk again about, you mentioned, so bottom line, this is not a consumer technology. It's about connecting machines to a word you guys heard a couple of times in this COSM, AI. And why is that combination so lethal? Is because one of the things that AI engines need is information. And consumer-driven information, as you said, whether it's come from Wi-Fi or from cellular or from Ethernet, who cares? It just comes there. And that's already a bank that they have. What AI engines don't have is the connection to the machines, to the sensors, to the robots. You know, until recently, to drones, we like to talk, lots of drones. You know, I was even amazed you guys talked about drone swarms. We're starting now to deal with a logistical center that is targeted to have 1,000 flying drones inside the premise. There's a ceiling on top, and there's going to be 1,000 of these guys flying around in the logistical center. That's why you need 5G. That is the purpose. And that layer of data and upload information, that is the one that uses 5G as glue to take you to the AI. And the third trend, which is the edge cloud, the part that was missing, kind of missing, where I then had to go all the way 1,000 miles away to meet an Azure data center. The Azure guys and the other guys, they're now moving to that edge. So I hope I kind of managed to explain in plain English, although that's not my native language, 5G, AI, and edge. That's the revolution that is in front of us.
How is Microsoft doing this?
Right, so we're trying to make things a little bit more ubiquitous. We're trying to make it so that you don't really know where your stuff is coming from. The old school of having a network where the network boundary was your security, dead to us. You can't hug your hard drives anymore. If you ask me where your data is stored in Azure, I might be able to get it down to a data center zone, one of 4 football fields worth of compute. But I could never tell you which device it's on, because even when it gets there, it's spread across devices. That sort of fully distributed computing is now becoming a globalized, fully distributed system. And in that environment, we have fast backplane to find things moving around, but we need equally fast connectivity to make it usable and useful. So now you could theoretically, there's lots of theory, there's speed of light limits. It's about how far away we can go. For the sake of math, let's call it 100 kilometers. Within 100 kilometers, everything feels like it's local. Super fast, picosecond connections, all good, fast backplane. But if you are in that space and you want to run 10,000 robot arms and make sure they don't swing into each other, you need an equally fast edge. And that's where 5G really comes in for us, is to connect it together.
Last year, we announced a project with Microsoft that we built the first 5G autonomous network in a factory in Taiwan. Taiwan was mentioned during these during this, and
occasionally.
And that was great, by the way, because the whole world was dead, but we could operate in Taiwan. They didn't even have one lockdown. They actually had their first lockdown 3 months ago. So we did it in Taiwan, all in the remote. We actually downloaded the 5G private network literally from our sofas at home in Israel to a factory in Taiwan. The infrastructure, not the app. You guys are following me? Okay. The infrastructure from a laptop in my house to a factory in Taiwan. We uploaded the 5G as software to their servers, and we built them an autonomous 5G private network. And you asked about, so the obvious for mobility, again, repeated, a robot and drone, because they move, you don't have a cable. Right? Today, a robot in an Intel site is dumb as whatever you want, pick a name. It just follows a barcode. At the end of the barcode space, it connects back and then it uploads its data. Well, now it can actually move like a remote controller and continuously upload its data. So it's a massive change. So that's obvious for mobility. But I'll give you the less obvious for mobility. Stationary machines. What we did in that program, actually, again, it's all public, you guys can go online and see it, is that we connected the old machinery in the factory that is already connected with a cable, a Cat5 or whatever the cable is, to doing something current, to a wireless link, a cellular link, which is cheap, and went directly to an AI engine. And actually that AI engine showed faults that the original machine was never designed to see. So the factory, you're refurbishing the old industrial world by doing very little, actually. You're just giving it another layer of information. So mobility here plays a role of, you don't have to rewire. It's mobile because it's mobile. And again, as we said, because this is all on-prem, on campus. And we didn't go into the technicalities here. But what it is you guys need to understand. In the old days, to build a network, whether it's private or not, was equipment roughly the size of this ballroom. Today, you can build a whole 5G private network that services a whole factory on a single Dell server that costs a Dell, an HPE, a Quanta, a server that costs $10,000. So for the cost of $10,000 worth of hardware, and the rest is profit to me and Microsoft, you can actually build a network that even in today's telco, with the existing vendors, is probably $1 million to $2 million to make, and in the old days cost about $200 million to make. And we can make it now for $10,000. And that's the disruption. We're getting to the point where this is all about software as a service and cloud, and the whole infrastructure is kind of a meaningless exercise.
Yeah, I want to reinforce the software-defined networks, software-defined networks. It's the big change. We're not buying hardware. You don't find things in plastic anymore. We define it as software inside the running systems. It's not only just faster in operation, because there's physics, but what you have is the ability to be a little bit more future-proofed. If we need to make a change, if there's a catastrophe or a failure in the system, it's a software making decision switch. Done. Move a new router, add a router, change a firewall, whatever you want, without buying a piece of software or a piece of hardware. That allows us, when we do collaborations, like between these two groups, to say, your software talks to my software, we know we have a loading point, and everything works.
No, we are not software-defined radio. We're an app on a server. The RAN software and the packet core are now apps. Actually, you can download them from the Azure Marketplace. It's an app like any other app. What you're missing, and maybe we should have started that way, is that our revolution of software would have not have happened with another bit of revolution, which is called OpenRAN, which means that the Quanta builds a hardware, a plain, dirty, cheap hardware radio, but it's Ethernet. It's like a networking. You understand a little bit about networking, right? So it's a networking device. We stick it up there, and it connects to a switch that goes into Azure.
Yep.
So it's not.
RAN is radio access network.
Open radio access networks. The other part, the geeks like to call vRAN, virtualization of radio access networks. So we're both plus cloud. Does that make sense now? Let's talk about the impact on businesses, and this is again not an original story. Let's say you're a factory in Taiwan and you want to build a safety app that prevents employees from getting their hands chopped off in the machine. So you tuned your 5G software, you tuned your applications that you got from Azure, and in the old world, that you would kept that knowledge to yourself, or maybe an Ericsson would have known about it, or maybe your operator would have known about it. Now, in this new, everything is connected. The same 5G version, remember I told you there's so many of those, connected to that application used in Taiwan, can be ported in milliseconds to another factory in Germany. That is really the significance of what we do. The rest, the architecture, the bits, great. But the cloud piece, the thing that connects that technology with application, is the one that's going to change the world.
And my industry is manufacturing, specifically using metals. Very low margin.
Closer to the mic.
Oh, I'm sorry. You can't hear either. Okay. Very, I need to be a little shorter, I think. So let's say we have a very low margin industry. Believe it or not, these guys have machines that sometimes they upgrade from DOS. All right, that's what's running them. And they have people that are driving forklifts around. I understand robotic forklifts. But who's going to build the equipment that's going to be able to benefit from the 5G? They don't make enough money to pay for the new equipment. So how does 5G help these thousands of industries that are making copper tubing and sheet and
Got it.
litho?
George, are these paid-in questions? No, it looks like you're part of my presentation. That's exactly it. Low-margin businesses are not... There's a company in Israel called Ogri. You know what they do? They listen to machines, right? We all, when we hear our refrigerator is about to break, we heard it. Turned enough in these metal factories or chemical plants, you can actually start hearing the grinding of the machine before it breaks. So what they did is they built sensors, and with AI, They listen to the machine, and they would tell you before it breaks. Even in a low-margin business, for you to know that you don't have downtime and to save the life of that machine, believe me, it worth a ton of money. By the way, they have a very simple business model, $1,000 per month per machine. And believe it or not, it's the old low-margin industries who pay the most because they have the oldest machines. So that's answer number one. What's the connection to 5G? Those sensors could be wired or they could be wireless. And the wireless is so much safer in machines that have moving parts. So that's a great example of the significance that this industry has now, because the Ogres, when they built that company 6 or 7 years ago, I met the founder and I said, how are you going to be connecting to the cloud? And he said, no, I'm bringing my own box. And that's what he does today. He still sells a box.
What's the name of this?
Augry, A-U-G-R-Y. They just, by the way, raised 250 million based on 2 billion valuation, which is easy these days. Augury, and they're changing the whole dynamics of German manufacturing, but specifically low margin, classical chemical, metal, scrap metal industries that are suffering the most from the lack of digitization, because a Intel factory is pretty highly aware of what's happening. It's the old stuff that like your business that is going to benefit the most. So thank you for that question. On the edge distribution specifically, that's public. We announced our first Azure compatible edge service in June, and I can share with you that the adoption rate is going to be pretty staggering. So, and that's really because I hope I managed to convince you it's really easy peasy, right? The big challenge you had about and why Wi-Fi was doing so well is that Wi-Fi was easy peasy and cellular was a nightmare. And now cellular is easy enough that you can, as we said, literally go in the marketplace, download it. You don't even manage that server anymore. And then you can control it in a language that you can understand. And that's really the big revolution.